Take a look at this fighter jet. It slices through the sky with incredible precision, pulling off turns that seem to defy physics. But here's the strange part. Many modern fighter jets aren't designed to be naturally stable. If their flight computers suddenly stopped working, some would become extremely difficult for a pilot to control as intended. Why would engineers build an aircraft that doesn't want to fly on its own? The answer is surprisingly simple. Stability makes an aircraft easier to fly, but instability makes it far more agile. And in the world of fighter jets, agility can make all the difference. So if these aircraft are intentionally unstable, what's really keeping them in the sky? The answer isn't just the pilot. It's an invisible computer making constant corrections every second. To understand why modern fighter jets need computers, we first need to understand stability. Think about throwing a dart. It naturally points forward and corrects itself as it flies. That's what engineers call a stable design. Now imagine trying to balance a pencil on your fingertip. The slightest movement sends it falling unless you make constant corrections. Many modern fighter jets are designed to behave more like that pencil than the dart. Why? Because an unstable aircraft can change direction much faster. It doesn't resist turning, it almost wants to turn. That gives pilots incredible maneuverability, but it also creates a problem. A human simply can't react fast enough to keep an unstable aircraft under control. That's why every movement of a modern fighter jet depends on something working silently in the background, a flight computer that never stops thinking. So what actually keeps a fighter jet in the air? Like every aircraft, it relies on four fundamental forces: lift, weight, thrust, and drag. Lift pushes the aircraft upward. Weight pulls it back toward Earth. Thrust from the engines drives it forward, while drag constantly tries to slow it down. For steady flight, these forces must remain in balance. But in a modern fighter jet, that balance is constantly changing. Every turn, every climb, every gust of wind shifts the forces acting on the aircraft. The pilot can't calculate those changes in real time. Instead, onboard computers monitor the aircraft continuously, making tiny adjustments to the control surfaces to keep everything balanced, often before the pilot even notices anything has changed. Without those invisible corrections, flying a modern fighter jet would be far more difficult than it appears. Imagine trying to balance that pencil again, but this time, it's traveling at hundreds of kilometers per hour through constantly changing air. That's the challenge a modern fighter jet faces every second. Even when the aircraft appears perfectly smooth from the outside, its control surfaces are making tiny, rapid movements almost continuously. They're responding to changing airflow, turbulence, speed, and the pilot's commands. These adjustments happen far faster than any human could react. In reality, the aircraft is never sitting perfectly still. It's being gently and continuously corrected by an invisible digital system working in the background. The jet may look effortless, but behind every perfectly controlled turn is a computer making thousands of tiny decisions to keep the aircraft exactly where it should be. So what is this invisible system? It's called fly-by-wire. In older aircraft, moving the control stick was connected directly to the control surfaces through mechanical cables and hydraulic systems. In a modern fighter jet, the pilot's input is first sent to powerful flight control computers. These computers receive information from dozens of sensors measuring speed, altitude, acceleration, angle of attack, and the aircraft's position in space. In just fractions of a second, they calculate the safest and most effective response, then command multiple control surfaces to move together with incredible precision. The pilot decides where the aircraft should go. The flight computer decides how to get it there. The flight computer isn't the only intelligent system on board. Even the engines have their own digital brain. Modern fighter jets use advanced engine control computers that constantly monitor fuel flow, air pressure, temperature, and engine speed. Every second, they make tiny adjustments to keep the engine producing maximum performance while preventing damage. Push the throttle forward, and the engine doesn't simply respond with more power. The computer calculates exactly how much fuel and airflow are needed. ensuring the engine delivers smooth, reliable thrust. While one computer keeps the aircraft stable, another keeps its engines operating at peak performance. Together, they transform raw power into controlled flight. With all this automation, you might wonder, is the computer flying the jet instead of the pilot? Not quite. The pilot still makes every important decision, when to climb, turn, dive, or avoid danger. But instead of moving the control surfaces directly, those commands are interpreted by the flight control computer. In an instant, it calculates the best way to perform the maneuver, coordinating the wings, tail, engine, and other control surfaces at the same time. The result is a partnership. The pilot provides the judgment, experience, and mission goals. The computer provides the speed, precision, and constant corrections that no human could ever make alone. Together, they become one of the most capable flying systems ever created. The next time you watch a fighter jet soar across the sky, remember, you're not just seeing powerful engines or advanced aerodynamics. You're witnessing millions of engineering decisions working together in perfect harmony. Modern fighter jets push the limits of what humans can control. Without their flight computers, many would lose the precision and agility that define them. The pilot may sit in the cockpit, but every second, invisible computers are working alongside them, making continuous corrections that keep the aircraft stable. In the end, the greatest breakthrough wasn't just building a faster fighter jet. It was teaching a machine how to fly it.